one giant building with interchangeable parts, which means if I take one column from a column and move it to another column, it will do just the same job, but it's not. You look at the Parthenon and you think that all the blocks are square in this building, but in fact, if you check it with a set square, please look at me now, with a set square, you will see that there is no single right angle, which means that everywhere there are curves. There is no single angle. As you may see the Parthenon and think that there are so many lines, straight lines, but in fact there are curves that are invisible to us because they are optical refinements to some illusions that the structure makes. In this, now I had planned to carry out a little experiment, but as I see, we don't have access to the monument. Well, I just wanted to say something. If a person stood over there with a book to the end of the stylobate, and if let's say Odysseus was there with a book, and we were here at the end of the stylobate, and Odysseus placed the book just down, we wouldn't be able to see it from here. This is because in the middle of the stylobate there is a curve about 6 centimeters high. And this is a paradox because you see the Parthenon and you think that all the floor is a straight line, but in fact there is a curve that goes something like this. I have a picture to show you. Do you see this? You think that these lines are not straight. You think that there is a curve. There is a little curve right here. But if you check it with this square, you can see that these lines are straight. What happens? These lines give us the illusion and we think that these lines make a curve. And that's why the ancient Greeks poured marble at the middle of the temple to do these optical refinements, as we say, in order to make this optical illusion disappear. The columns link to the inside of the temple. So they gave us the ancient Greek so that Lord made a curve in the middle. So they put more marble in order to make it linear. Okay, let's move on. Now Odysseus is going to tell you something more about the curves. I mean that every
Danish students don't care about ancient mathematicians, I think.
The Parthenon is regarded as the finest example of Greek architecture. Even in antiquity, its architectural refinements were legendary, especially the subtle correspondence between the curvature of the syllabat, which is the floor and makes this kind of shape around its center, and the taper of the naos walls, and the edifices of the columns. What is edifices? Edifices refers to the slight swelling of 1/8 inch to 1/5 of the height of the columns to counteract the appearance of columns having a waist, which means that right about the center and at the 2/5 of the column up high, the columns tend to swell a little bit and then go up again. Have it. When they swell, it's called edifices, and when they go back and get thinner towards the top, it's called meiosis.
like it, but it was bread without gluten. Κάθε μέρα θα το κάνω αυτό, έχω πάρει εγώ. Για το ψωμί.
Okay. Meiosis is the slimming of the thickness of the columns around the top part. The reduction is not uniform and follows a peculiar curve, and acts as the counterpart to edifices. Just as they swell around the top, they get thinner around the bottom. They get thinner around the top. No distance between the columns is exactly the same, while the columns at each four corners are slightly larger and further away. The columns that are found at the four corners, this one, the other one, and the two we saw at the beginning, are slightly larger. The details not immediately apparent to the naked eye provide the building with unparalleled harmony and life. Moreover, we have to look at its positioning in space, because I don't know if you noticed, but when we walked in through the Propylaea, we didn't see the face, the facade, as I told before, of the temple. We saw its whole body, so a visitor can see its entire length and how it looks like as a whole.
Okay, but the question is, how did they manage to make these curves on the columns? You know, because we say that there is a slight swelling, a slight curve in the middle of the columns, but how did they do that? The indices curve, as Odysseus said, on the side of the column is so slight, restorers can only draw it by a computer. So restorers that study the curves of the Parthenon can only draw this curve by computer. For the ancients to have drawn it full scale, they would have had to set the compass at an impossible radius of near a mile. I want you to understand that if they had to make this curve, they had to put the compass at the center of the circle to a radius over a mile, and then draw a circle in order to succeed this kind of curve. The answer to this puzzle came by Germans while investigating an ancient Greek temple in Turkey. They discovered that the Greeks scaled down the height of the column. Let's say that this is our column. Okay, and we have a slight curve, a slight swelling at the middle of the column. What ancients did was to scale down the height, only the height of the column, by a factor of 16, and then the column turned out to be this. The genius behind this table, okay, the genius thing behind this table was that the width of the column was not scaled down. So now we have a smaller circle with a smaller radius which can be drawn, and at the same time we have still the radius of a column. So now the only thing the ancients have to do is to put their compass at this width and have the diameter of every column, and in this way they built one column drum after another, and they built the column with this slight curve and this slight swelling. And okay, consequently, each and every piece of the Parthenon is unique, and that's why its restoration is very challenging and difficult job. There is only one piece that fits into a specific position, which means that if I find a rock, a stone that is from one column of the Parthenon, there is only one position that this piece fits. I can put it into another piece's position. So this is really difficult actually. So what about mathematics? What we have found is that the Parthenon was built with extremely precise dimensions according to the mathematical ratios of sacred geometry. What is sacred geometry? Sacred geometry is proportions that were thought to be given by God. God used these proportions in the creation of the world. So the beautiful, they're aesthetically correct. So they try to use this proportion, this sacred geometry in the construction of the Parthenon, which the Parthenon, the jewel of, not the jewel, the jewel of Athens. We can see that these dimensions of the Parthenon have been decided by the architects of the temple according to the ratio 4 to 9, which means that if I take the length of the Parthenon and multiply it by 4 and divide it by 9, now I have the width of the Parthenon. And if I take the width of the Parthenon and I multiply it by 4 and divide it by 9, I have the height of the Parthenon. Another proportion that is hidden in the structural characteristics of Parthenon is the number phi, known as golden ratio or golden section. How many of you have listened or have heard of golden section? Golden section? Golden section? Everyone knows that. You know, golden section, two quantities A and B are said to be in golden ratio phi. Can you hold that? Thank you. Now, I have built this tool. This tool here is constructed based on the pentagram, which is a star with all its sides equal. This gives us the proportion of golden section, which means that if this distance here is 1 meter, this one is 1.6 is the number phi. The ratio of these two dimensions is equal to the golden section. As you can see, Parthenon is full of this ratio. I have some pictures here to show you. Odysseus before said about metals. We have here this. Okay, we have here these blocks, which are the top marbles of the Parthenon. We can see that there is a golden ratio. You can see that. Can you see everybody? There is golden ratio. If I put this is the golden ratio proportion with this dimension. The same here. And we can see that golden ratio is everywhere in the Parthenon. Beautiful mathematics that combine together in order to make this majestic monument.
Very nice, thank you.
Thank you very much.